Dear students, this is SANAL from Physics Login. Today we are going to solve this question. So you have two blocks, okay, block A and B. One is having high rigidity and one is having low rigidity. Both are cubical block, okay. So this arrangement is set up in such a way that you can see that they have mentioned that the lower face of A is completely covers the upper face of B, and the lower face of B is rigidly held to the horizontal surface. This lower part of B is rigidly, which is not allowed to move, okay, fixed here. And then what you are seeing, a small force F is applied perpendicular to one of the sides of the face A. That means you are applying a force, a small force F here. What happened? The below body is less rigid. What happened? The surface will move, right? So you need to find out what and after release of this force, it is oscillating. So you need to find out what the force withdrawn. After withdrawal of the force, the block A is executing a small oscillation. So the time period of that oscillation you need to find out. So when you push this one, you know that this upper surface will move here like this, right? When you push it and when you then release it, what happens? It will oscillate. So let's say this angle is theta. And modulus of rigidity. Modulus of rigidity, what is the formula? Or shear modulus is what? F upon A divided by theta, right? Shear stress by shear strain. So this formula, you can apply this formula from here. F is equal to eta A theta. So time period of oscillation, general formula, what is that? Time period is equal to 2 pi into root of M upon K, right? You need to find out the force constant. So because oscillation, what is the force? F is equal to minus Kx, okay? So you can rearrange this. You can check this equation. F is equal to eta A theta. So since it is moving, let's say this has moved X distance, then this is X. They have given that they are having the same dimension. So the side length will be L, right? So when you consider, and one more thing they have mentioned here, you can see that it's applied with a very small force. Very small force means you angle will be very small. And this angle is very small means what? For small angles, for very small angles, sine theta is approximately equal to theta, which is also approximately equal to tan theta, right? This thing you need to remember. So you can say tan theta is equal to, how can you take that? Opposite side by adjacent side. So you can write it as theta is equal to opposite side x by L. So you check this one, eta into area of cross section. If you check this diagram, this is a cubical, right? This area you are applying the force. So it will be L square into what is theta? X upon L. So this will get cancelled. The force equation you are getting is what? Eta L into X. So when you compare this with your force equation of oscillation, what is that? This thing is your force constant, right? K. So time period T is equal to 2 pi root of M upon, what is this one? K eta L. So you check the options, 2 pi root of ml eta L, right? Eta L. So this will be the answer. Okay. So if you feel that this video is useful, just like, subscribe, and press the bell icon for the next video. Thank you.